Hello students, in this video today we are going to solve the problems of exercise 13.1 of NCERT textbook of mathematics class 11. Okay, so this is part 3. So I have already made two videos on this exercise where I have solved from question number 1 to 25 already, and links of those videos are provided in the description box. Please go through them. Okay, and in this video I'm going to show you how to solve from question number 26 to question number 32. Okay, here this exercise will be completed. Okay, now let me show you how to solve question number 26. Okay, so here it is given the function f of x is equal to x by mod of x when x is not equal to 0, and it is equal to 0 when x is equal to 0. Okay, so we need to find the limit of fx as x tends to 0. So here in this case we are going to find first left hand limit. Okay, left hand limit. So here limit f of x as x tends to 0, 0 negative means left hand limit, that's gonna be equal to for less than 0. So here left hand limit x tends to 0 negative, so here is x by mod of x. Okay, so now you see left hand limit, in this case x must be less than 0. Okay, x must be less than 0. So in that case what to write? Limit x by minus x as x tends to 0 negative. Okay, so actually we have to write this here x by minus x. Okay, we know this. If suppose mod of x, actually mod of x, what does it mean? It means mod of x, it is equal to minus x if x is less than 0, and it is x when x is greater than 0, greater than equal to 0. Okay, so we know this function. Okay, so that's why we are using this concept here. So in this case it will be minus 1. Okay, now let us find the right hand limit. Okay, so here limit, so here we are going to write x positive means right hand limit f of x, which is going to be equal to limit x tends to 0 positive here. So now we are taking x by x because we are taking this for x greater than 0 for right hand limit. Okay, so hope you got it. So then its result will be plus 1. Okay, here you see in this case left hand limit and right hand limit are not equal. Since left hand limit is not equal to right hand limit, therefore limit f of x as x tends to 0 does not exist. Okay, so that is question number 26. That's how we can solve. Now let me show you how to solve question number 27. Okay, so find the limit of fx as x tends to 5 where f of x is mod of x minus 5. Okay, so let me show you how to solve this. Okay, so here is the solution. So here given that the function f of x is mod of x minus 5. So how to find the limit? Let us find the left hand limit first. Here also left hand limit limit. So in order to find the limit x tends to 5, in order to find the left hand limit, we need to write here 5 negative of fx. So that means x is slightly less than 5. Okay, difference is not so huge. It's a number in the neighborhood of 5. Okay, it is slightly less than 5. Okay, so we know that mod of x is equal to minus x when x is less than equal to 0. Okay, or you can say less than 0, and it is plus x when x is greater than equal to 0. Okay, but in this case we are not taking x tends to 0, we are taking x tends to 5. We are going to find the limit of this function for x tends to 5, for x tends to 5. Okay, that's why in this case for both left hand and right hand limit we have to take positive value of x. Okay, we will take x as positive. Okay, in this case, so here limit x tends to 5 negative, here we are going to take x minus 5 here. Okay, so then its value will be 5 minus 5, then it will be 0. Okay, now let us find the right hand limit. Okay, right hand limit of f of x, x tends to 5 positive. Okay, 5 positive, that means x is slightly greater than 5. Okay, so in this case limit x minus 5, here also x minus 5, as x tends to 5 positive. This positive sign represents the right hand limit. Okay, so here also our answer is, let me rewrite this one. Yeah, 5 minus 5, that's gonna be equal to 0. So as we can see, left hand limit equal to right hand limit, both equal to 0. Therefore we can say limit of f of x as x tends to 5 is equal to 0. So that's how we can solve this. Okay, now let us solve question number 28. So here you see, so here one function f of x is given. Okay, which is equal to a plus bx when x is less than 1, and it is equal to 4 when x is equal to 1, and it is b minus ax when x is greater than 1. Okay, and also it is given limit of f of x as x tends to 1 is equal to f of 1. That means this limit does exist. Okay, we need to find the possible values of a and b. Okay, we need to find the possible values of a and b. Okay, now let me show you how to solve this. Okay, so here our function is f of x, which is equal to, so let me, okay, a plus bx when x is less than 1, it is equal to 4 when x is equal to 1, and it is b minus ax when x is greater than 1. Okay, so these three things are given. Okay, so let me use. Okay, so now you see, let us find the left hand limit first. Left hand limit, which is limit f of x, x tends to 1 negative, 1 negative, that means it represents the left hand limit. Okay, so then we have to take x tends to 1 negative, that means it is slightly less than 1, so that's why we need to take this value here, a plus bx. Okay, so we have to write a plus bx. Now if you put 1, then it will be a plus b. So similarly we can find the right hand limit as well. So limit of f of x, x tends to 1 positive, that means right hand limit. So limit x tends to 1 positive means slightly greater than 1. So in this case we have to take this value for x greater than 1. So we have to take b minus a x. On putting the value of x, we will get b minus a. Okay, so here you see one more thing is given also. Given that limit of the function f of x as x tends to 1 is equal to f of 1. Okay, and we know for x equal to 1, for x is equal to 1, f of x is 4. That means we can say f of 1 is equal to 4. So we can write is equal to 4, because you see for x is equal to 1, here you see its value is 4. So x is equal to 1 means f of 1 is equal to 4. Okay, so that's why we can write, as you can see, this value, its value of this limit is 4. That's why left hand limit, right hand limit, left hand limit and right hand limit as x tends to 0, both must be equal to 4 in this case. And here we have got the left hand limit is a plus b, and the right hand limit we have got b minus a. So let's put these values. Okay, so we will get a plus b is equal to b minus a is equal to 4. Okay, so let me solve this part here. Okay, so we can obtain the value of a and b by solving these two. Okay, how to solve? So first let us take a plus b is equal to 4. Okay, let us take this part, a plus b is equal to 4. Then let us take b minus a is equal to 4. Okay, b minus a is equal to 4. So b minus a is equal to 4. Now let us solve these two part. Okay, now let us solve these two. So how to solve these two? So here you see, so let us give this one as 1, this is 2. So if you add 1 and 2, then what will happen? Here a minus a plus a will be cancelled, minus a plus a will be cancelled, and b plus b will be twice b, and 4 plus 4, 4 plus 4 is equal to 8. That means b is equal to 4 after cancelling both side by 2. After cancelling both side by 2, we will get b equal to 4. Hope you understood that. Now let us put this value of b, putting b is equal to 4 in 1, suppose. Then what we will get? A plus 4 is equal to 4. That means here 4 cancel, we will get a is equal to 0. So possible values of a and r, so let me write the 0 properly. Okay, this is 0. So possible values of a and b are a equal to 0, b is equal to 4. That's how we can solve this question number 28. Now let me show you how to solve question number 29. Let a1, a2, dot 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 an be fixed real numbers. So these are fixed real numbers. Define a function f of x which is equal to x minus x1 into x minus x2 dot 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 and so on, x minus an. Okay, so here it is asked what is limit f of x tends to ai. For a is a not equal to a is not equal to a1, a2 dot 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 an, we need to find limit of fx as x tends to a. Okay, first we need to find this limit of fx as x tends to ai. Then we need to find this limit of fx as x tends to a, where a is not equal to a1. Okay, so let me show you how to solve this one. Okay, so here the function is f of x is equal to x minus a1 into x minus a2 into dot 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 x minus an. Okay, x minus an. So where a1 a2, these are an are real numbers, okay, are real numbers. These are all real numbers, okay. So now you see, in this case, for limit f of x tends to ai. So ai means here i is equal to 1 2 3 dot 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 so on, okay. Then here limit of this will be, so let me write like this first, x tends to ai. So here ai a1 ai a2, then ai minus a3 dot 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 so on, ai minus an, okay. So for these values, you see, for I is equal to 1, ai minus a1 is equal to a1 minus a1, that is equal to 0, okay. If you put 0 here, this whole thing becomes 0. So therefore limit of f of x as x tends to ai must be equal to 0, okay. Hope you have understood this, how we have got 0, okay. Now let's find limit of fx as x tends to a. Limit of f of x as x tends to a, here it will be limit of x tends to a, x minus a1 x minus a2 dot 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 so on, x to the x minus an. So here one more thing is given, that a is not equal to a1, that's why its value is not going to be equal to 0 in this case. So that's why we will get limit, not limit. Now you can replace the value of x by a. So we will get a minus a1 into a minus a2 into a minus a3 and so on, a minus an. So that is the result, okay. That's how we can solve this, okay. Now let me show you how to solve question number 30. Here you can see this function fx is given, and it is equal to mod of x plus 1 when x is less than 0, and it is 0 when x is equal to 0, and it is mod of x minus 1 when x is greater than 0. So for what values of a does the limit of f of x as x tends to a exist, okay. So for what value of a this limit exists, we need to find that out, okay. So now let me show you how to solve this one. Solution. So here the given function is this one. So let me write the given function first. So here x is less than 0. For 0 x is equal to 0, and it is x minus 1, mod of x minus 1 for x greater than 0, okay. So this is the given function. So okay, so we also know that mod of x, so let me take another ink, okay. Mod of x is equal to, it is minus x for x is less than 0, and it is plus x for x is greater than 0, okay. We have got these two cases, one is this one, another is this one, okay. So now here you see, if we take for a greater than 0, okay, for a greater than 0, so limit of f of x as x tends to a. So we know that, you can see this function is, value of this function is mod of x plus 1 when x is less than 0. So let me take the less than 0 first, okay. A is less than 0, okay. So its value always gonna be mod of so first let me write here mod of x plus 1 x tends to a. And here one more thing you can do, not only, don't write the mod here. So as we have already got that mod of x is negative, as a negative x, as x is less than 0, here we are taking a is less than 0, that's why we have to write here minus x. Okay, then put x is equal to a, then it will be minus a plus 1. So here you see one more thing, we are calculating this for less than 0. Okay, so if you take any neighboring point of a, okay, any point in the neighborhood of the of the value a, as a is less than 0, those value will be also less than 0, and for those values function value of this function is always of this kind, minus a plus 1. Okay, it's not going to change. That means for a less than 0, this limit exists. Okay, so now similarly for a greater than 0, limit of f of x x tends to a, limit of, so for x greater than 0, here you see for x greater than 0, the value is mod of x minus 1. Okay, so and for x greater than 0, x is positive, so here we can take x plus 1, x tends to a for a greater than 0, and it will be a plus 1. Okay, when a is greater than 0, if you take any value in the neighborhood of the the number a, then value of this function is not going to change, it remains same. Okay, so that means this limit does exist for all a greater than 0. Okay, so we can write therefore limit of f of x when x tends to 0, sorry not 0, x tends to a, exist for all a greater than 0 and a less than 0. Okay, in both the cases. Now for a is equal to 0, for a equal to 0, so when you take a equal to 0, then what will happen? So let us find left hand limit and right hand limit. So here we have to find left hand limit, right hand limit, because you see for the value left hand, on the left hand side of 0, x equal to 0, its value is this one, and on the right hand side it is this one. Okay, so here we will get limit x tends to 0 positive, sorry, for left hand side we have to take 0 negative. Okay, f of x, that's gonna be so for left hand limit we have to put the put 0 here. Okay, because now we are taking the left hand limit, that means x is slightly less than 0, so here it will be limit of minus x plus 1 as x tends to 0 negative, which is going to be equal to, sorry, minus 0 plus 1 means 1. Okay, so now let's find the right hand limit. Right hand limit, so limit of f of x x tends to 0 positive. So let me scroll up the page. 0 positive means, so it is slightly greater than 0, and for greater than 0, here you can see now we have to move towards right hand side of the value 0. Okay, so for this it is mod of x plus 1. Okay, sorry, mod of x minus 1. So we can write here limit x plus 1, not plus 1, sorry, minus 1, here x tends to 0 positive. Okay, in this case it will be 0 minus 1, that will be minus 1. So here you see left hand side and right hand side not equal, are not equal. Left hand limit is not equal to right hand limit, in this case right hand limit. So limit of f of x, x tends to 0, does not exist. Does not exist. So what we can say, so we have got that this function exists for a greater than 0, less than 0, but it doesn't exist as x tends to 0. Okay, so value of a can be anything other than 0. Okay, therefore limit of f of x, x tends to a, exist for all values of a other than a is equal to 0. Only at this point this limit doesn't exist, otherwise it does exist. Okay, so hope you have understood this. Now let me show you how to solve 31. Here this function f of x satisfies this condition, that limit of f of x minus 2 by x square minus 1 x as x tends to 1 is equal to pi. Then we need to evaluate this limit of f of x as x tends to 1. Okay, let me show you how to solve this. Okay, here it is given limit of f of x minus 2. So let me write clearly, f of x minus 2 by x square minus 1 as x tends to 1 is equal to pi. So here you see we can write this left hand side as like this. Now you say limit of f of x by g of x. Suppose x tends to something, suppose c, then we can write limit of f of x as x tends to c by limit of g of x as x tends to c, isn't it? So here also we can apply this same method. Here limit x tends to 1, limit of f of x minus 2 here by limit of x square minus 1 as x tends to 1. Okay, here it will be pi. So after cross multiplication, here we will get limit of f of x minus 2 as x tends to 1 is equal to, so here it should be pi into limit x square minus 1 x tends to 1. So here you see on the right hand side this is gonna be 1 square minus 1, that's gonna be 0, pi into 0, that will be 0. Okay, so therefore limit of any constant is that constant. So here we will get limit of f of x as x tends to 1 minus limit of 2 as x tends to 1 remains 2, and here it is 0, which implies limit of f of x as x tends to 1 is equal to 2. So this is our solution. So hope you have understood. Now let me solve 32. Here you see this function is given. So when x is less than 0, so it is equal to mx square plus n, and when x is greater than equal to 0, less than equal to 1, its value is nx plus m, and it is nx square plus m when it is x greater than 1. Okay, when x is greater than 1. So we need to find for what integers m and n does both these two limits exist. Okay, so now let me show you how to solve. So here you see f of x is equal to, here mx square plus n when x is less than 0, and it is nx plus m when x is greater than equal to 0 and less than equal to 1, and it is nx square plus m when x is greater than 1. So in order to find a limit, in order to find the limit f of x tends to 0 as x tends to 0, So in order to find the let us check the existence of this function, existence of this limit. So in order to check that, we need to find the left hand limit and right hand limit. So left hand limit here, when limit x tends to 0 negative, okay, f of x, which is gonna be equal to limit of x tends to 0 negative. So here in this case, left hand limit is this one. So for x less than 0, we have to take this one here. So we can write m x square plus n. Okay, so if you put 0, what you will get? You will get m into 0 square plus n, that's going to be equal to n. So let's take right hand limit. X tends to 0 positive, f of x, and in this case we have to take this nx square plus m, x tends to 1. Okay, here we have to take limit of nx square plus m as x tends to 0 positive. So it will be n into 0 square plus m, that's going to be again m. So now you see this limit will exist if and if only left hand limit is equal to right hand limit, which implies that here you see left hand limit is n, right hand limit is m, which implies n is equal to m. Okay, so therefore we can say limit x tends to 0, limit of f of x tends to 0 exist for m is equal to n. Okay, for m is equal to n. Okay, where m and n belongs to z, that means they are integers. Okay, so now let us evaluate this. So in this case, let me scroll up again. Now left hand limit, where limit of f of x as x tends to 1 negative. So here for less than equal to 1, it is nx plus m. So we have to write a limit nx plus m, x tends to 1 negative. So if you put 1 here, n into 1 plus m, that is n plus m. So right hand limit, so limit x tends to 1 positive of fx. So limit, this is 1 positive. So for greater than 1, we have got this one, nx square plus m. So let's put here nx square plus m. So if when you will put 1, then n into 1 square plus m, that's going to be again n plus m. So here you see both left hand and right hand limits are equal. Okay, so that's why let me scroll up. That's why limit x tends to, sorry, not 0, x tends to 1, f of x exist for any integers m and n. So hope you have understood this. So this exercise is completed. So if you like my video, if you think this video is helpful, then please subscribe it and hit the thumbs up button, and also share my videos. Thank you for watching.